So let's go over data structures. So I'm gonna go inside first person player, and in here we are just gonna go over different types. So let's first start with a struct. So a struct is basically an asset that you can create. So I can go to blueprints, structure, let's name it test struct. Let's open it up. And the struct is basically a container of multiple values, and you can basically have whatever you want. So you can have integers, arrays, strings, maps, whatever you want basically in here. And what we can do then is in any project, we can just type test struct, get our struct type. And in here now we have access to it, we can save stuff into it, we can load it. And the pros of structs is basically that all the data is grouped together. So whenever you have a struct, you can basically open it up, get all your data and manage it. The good thing is also that it saves everything in the same place in memory. So usually when you have multiple variables, they might be in different places in memory, but structs combine all of the data into one place. So that's also a good thing. Now the bad thing about struct is just that every time you want to access just one value, you kind of have to open up the whole struct and deal with everything, which can have a little bit of an overhead when you are working with them. And also when you change, so if you want to set a struct, you might have to do something like this, where you connect everything that you already have to kind of keep it the same, so you don't keep it empty, and then change whatever you want inside of the struct. So that kind of can get complicated. So structs are usually good when you kind of want to bundle something together. So maybe, let's say an item or something has multiple things, and then you can use structs to kind of bundle, I don't know, item name, maybe item type, stuff like that. So you can bundle it all together. So then when you want to access it, you usually want to access multiple stuff, not just one thing. You can also use it to maybe save player stats. So if you have like health, stamina, energy, you can all save it in one place. Or you can use it like for player's attributes. So maybe he has like strength, dexterity, stuff like that. You can all put it in one struct instead of having 5, 6, 7 different variables that you would have to save. Okay, so the next thing that we have is arrays. So this is the most common one. So if you create a variable, you can basically go to any variable, or most of the variables can be arrays. So you can do this, and this basically means that now you have a list of integers basically. So if I compile save, we can in here just create a list. And the good thing about arrays is that they are ordered and they go by index. So at any point, if you want to get an index 3, whatever is in there, you're gonna get it. So you don't have to look at it by any value, you can just look at it by index, which is good for things like loops, or if you already have things ordered, maybe you have like multiple arrays that you keep different stuff in, and then you can kind of access by index, by the same index on both arrays or something like that. So it depends on basically what you want to use it. Good thing is about arrays also is that they are dynamic in size. That means that at any point in the game you can just increase the size or decrease the size of your array. While let's say for structs you cannot add variables at runtime. For struct you have to keep it the same size or the same content as you did when you created it in editor. The one issue that you can kind of get with arrays is if you want to search something in an array and you have a bunch of stuff, you might have to do something like for loop and then check the contents. So that's kind of a thing where you can't look up by any other metric except the index for the stuff. So if you have, let's say, string, if you have your string array and you have different names here, you might want to see, okay, do I have a specific name in this array? You will have to go through each index and hope that whatever you're searching for is in the lower indexes, so you can kind of stop the loop earlier or something, but you're just going to have to loop through it because all you have access to is index. So that's kind of an important thing for arrays, but of course there is different data structure that you can use to kind of mitigate this. Okay, so the next thing is sets. So let's create new variable and let's just make it a set. Now, the difference between set and an integer or an array is that it has unique indexes. That basically means that you can't have multiple of the same type, or not the same indexes, the same information in the variable. So if I type in here A, now I can create a new one, name it B, but if I try to create a new one and try to go forward, it cannot create a new one because new one is empty and we already have an empty. So you have to change this to create more. So good thing about set is that it is unique. So you kind of ensure by using a set, you ensure that everything in your blueprint is unique. So you'll never have something of the same type. So you cannot have like multiple instances of the same thing. So that's kind of a good thing about set. So one thing that maybe we can use it for is, let's say you have unique items in a game and you want to ensure that you can only have one of those. You can have a set list, and then when you try to access and find that item, you are ensured that it only has one instance of it. And then you also have unique, this is also, I didn't cover this, but you also have different operations. So you can do different stuff to basically manage this set. So you can add new items, you can clear the set, you can find if it contains a specific item that you're searching for. You can see the difference between the other sets. So if you maybe have multiple sets, you can see if they're equal or not. You check if it's empty, check the length, how many items it has, and you can remove specific items or even create it to an array and then manage array, because array has different operators or stuff that you can do with them. So if you do contains items, you can do a specific, let's say, unique item, and then you can check if it exists or not. So you kind of know right away. Well, let's go back to array. And let's go to operations here. Let's go to utilities, array. Now we have a few more stuff. Good thing about array is that you can kind of recruit them in different ways. So you can append it. Basically, you can just connect two arrays and it's going to work fine because you don't need unique items in an array. You can check if it contains item or to find item. The difference is that contains item only has the true or false output, while the find item gives you a specific index where that item is. So if you saw in the set, when we were searching for stuff, it only gave me a boolean of true or false, so you can check if it's somewhere, but it doesn't know where. Let's go back to an array. You can get a copy, so you can check by index and get a specific copy of an item. You can, of course, for loop. You can check if it's identical with another array. Let's see which else we have. You can check the last index, so you don't have to check the length. You can just get the last index, which is kind of similar, but last index is -1 since it starts with 0. So 0 to 10 will actually be 11 items, and the length will give you 11, while the last index will give you 10, basically. You can also get just a random array element, so this is good if you just have random stuff and you just want to get whatever from the list. So one use for this might be, maybe you have like a terrain generator and you have different versions of, let's say, a road tile, so you can basically just get a random array element. You don't care about which mesh you're taking, you just want it to be road or something. You can resize it, you can go from reverse the elements in array, you can just shuffle it at random. So a bunch of operations here, so we can say we have more flexibility, but there is also the downsides that we talked about. Next thing is maps. A map basically has a key and a value, and what that means is basically you can look up the key and get the values. So if I type something here, and this, by the way, key always has to be unique, so I cannot put plus here, and then the values can be whatever. So it's almost like a combination of a set and array. And when we get the map, we can go to utilities, map, and we can see we have a few things in here, but of course not that many options as arrays. So the most important ones that I didn't cover before is keys and values. So I can get the keys in an array, or I can get values in an array, and then that way I can loop it, do stuff like that, while I cannot loop if we are in here. And you have this option find, which is nice. So you get a branch or you get a boolean to tell you if you found the item or not, and then you get the actual index of that item. So you know where the location is, so you can later retrieve it if you want. Good thing for maps is maybe if you want to use it for, let's say, inventory system. So if I had like item 1 and I had 5 of those, 5 quantity of those items, I can have item 2, maybe I have 2. So you can go like that, and at any point if you have, let's say, item 2 again, it won't be valid. So then when you are adding the item, you can check, does this item already exist? Oh, it does. Let me just add, combine the quantities so I can add more to it, and then you just have bigger quantity. So that's kind of an easy use of the map. The data in the map is an order, so you don't have the indexes the same way as you have an array, so that's why you have to kind of get it in the keys or get it in the values. And maps also use a bit more memory than, let's say, an array, because you have multiple stuff to manage. You have your keys, your values, and then how they relate to each other. And you kind of have the same unordered issue with set, so you cannot just like for loop it with indexes. You have to convert it to an array and then do that. They can be useful in their own ways, so you can think about basically how each of them can be used. The next thing that we have are enums, and enum is also a type that you need to create. So I can right click, go to blueprints, click on enum, let's do test enum, and usually this data structure I name name, then this slash, and then whatever the name of the structure is. And enums are basically lists of names essentially, so you can have like what can we have? Usually enums are good for states, so I can do like idle, running, walking, stuff like that. And then in here, and now in here we can see that we have our options that we had before. Important thing to keep in mind with enums is that they are limited to whatever you put in this list, and you cannot expand this list at runtime. So you kind of work with that, but they are pretty lightweight and easy to use. So how you would usually use these enums is pull from them and then type switch, and you can just do something like this and then select what you want to do for each state. Also, what you can do with enums is, let's say you don't even have a variable in your blueprint, they're project wide. So what I can do is type test enum, and then I have different options. So I can do for each. So we can just loop through this enum list, and for each enum type we can maybe do switch, or maybe check if it's equal. So if it's equal to idle, maybe we just want to loop and check if one of them is whatever idle or something, or equal to maybe our other state. So maybe we have an enum in here and we can connect it and check which one is equal, and then we can do a specific thing there. So that's kind of a good thing. They are kind of project wide, but the biggest thing about them that is kind of a downside is that they cannot be expanded at runtime. So whatever you create, you kind of have. Yeah, also good thing, since they're named, they're more readable. If you had like an array of indexes or of integers, you would have like 0, 1, 2, and you wouldn't know, or it will be harder for your code to be read. Someone would have to be familiar with what each index does. This way you have a named list, basically. Last two things that you're gonna cover is data tables and data assets. Data tables are basically a list where you have different tabs, and for each tab you can do something. So let me see if we already have a few of them made, but let's actually create our own. So how you can create a structure for your data table is use structure, or you can also load an external file, but we won't go into that. That gets a bit more complicated. But you have a struct. What you can do is open it up. So let's say we have a boolean. Let's name it bool. We can have maybe, I'm just gonna name them just so we have something. Let's name it dt struct. And let's find it in here, and let's click OK. Let's name it like that. And now this is our data table. So in here you can see we have our bool, our int, and basically it could be any value that you want. It can even be like object references, maps, arrays, stuff like that. It's all that you can see in here when I add something. So now we can select the state of this. We can name the row. So row you can treat like an index, or you can treat like a type. So maybe we want like maybe we want to type like shield, and what are the stats for the shield. Maybe we want to do like sword 1 something, and you can have different stats for each. So maybe something like this, and then get data table row. So this is usually how you would access it. And in here we need to select our test data table, and now we have our rows, and we can basically select from them. Now, as I said before, you can treat this like indexes if you want. So you can basically do maybe like index 5 or something, but you can also treat it more like you would treat enums, where you have a list of objects, and you can basically get your row and then get all your data for the object. So this is a good way to basically check, okay, do we have this item in the data table? If we do, let's get some information from it. So what are the stats for the sword? What are the stats for the shield? You can easily access it like this. Good thing about data table is that they store data in the same place. So they're kind of like structs, and you have a nice easy access with them. So they're kind of user friendly or developer friendly, I guess. where you can easily access it, easily go into it and do stuff. Bad thing about them is that they are basically read-only, so you cannot add new stuff at runtime. Your data table is kind of set. And also the access to data tables is usually just by rows. So if I do data table, so I can check if row exists. I can get data table row names, but that's kind of it. You kind of just access it by the row. There are some plugins to extend this, so you can kind of search for maybe a value and then search by value or something. But in general, this is kind of what you get by default. So unless you expand with plugin, there is not much access ways basically for information. The last one will be a data asset. So let's go to blueprint class. Let's type data asset. And these guys are pretty useful for, let's name it, I usually name it PDA. So this is kind of the base class, and let's name it, let's do ability. I'm just gonna name it ability base, just to kind of give you an example of how you can use it. So let's say you have different abilities in your game, and you can use basically data assets to kind of structure their the system. So maybe we have damage. So how much does your ability deal damage? We can do ability type, and then in here maybe you have an enum. Now I'm just gonna do an example enum. You would of course create your own and have maybe what type of ability this is. Maybe you can do like cast time, I don't know, particles, like our system, I think would be object reference. So you can do a bunch of like values that you have, that you want your every ability to have. Then what you can do is go to miscellaneous, go data asset, find your ability base, select, and we can name it maybe data asset fireball. And now we created basically an instance of PD ability base. If I open this up, we have your damage. We can do something enum, we can do cast time, and maybe we have a particle simple explosion. Now we have basically a template for our fireball, and we can use this for as many as we want. We can create multiple instances of this PD ability base. And the good thing about this is that if we go to our character now, what we can do is select a variable, type PDA, get object reference, and now we can select any child of our base class. So for example, we can have another, let's do heal. And if we go here, we can have that ability too. Good thing about this is basically that you have kind of an access, and there are access to your data asset, and it's dynamic. You can change it at runtime. So at any point I can do set, and I want to now this be fireball. Maybe this is like a current player active ability. We can do something like that. What you can do is if you save it, if you have it as object reference, we can do get maybe damage. We can get any variable that you want basically, and they're basically pretty efficient. They're kind of like objects. You can imagine if you created, let's say, blueprint class an object. So this is something that you can spawn in the level, but it can hold values. So it's kind of similar like this, but this is kind of less efficient because it's not specialized for this. The object is just kind of a general class, but data asset is specialized for storing data and retrieving it at runtime, and also changing, managing it. So it's kind of efficient in that way. And you can also change values. So maybe for some reason your damage has just doubled for this ability. You can just do whatever you can do. Maybe this, access your ability, change it, and now your fireball only on this instance. Of course, it won't change if you change it, but only on this instance now your damage has double damage or something, or if fireball has double damage. So yeah, they are pretty nice. You can use them for a bunch of stuff, not just for abilities. You can do it for like item types, weapon types. You can use it for a bunch of stuff. Yeah, you can also maybe use it for attributes. So this depends if you are creating characters and you have a character that has health, stamina, energy, inventory, maybe items that he has in hand, maybe modifiers for like strength, dexterity, intelligence. You can have all of that stored in a data table, and then you can have like a generic version. So maybe you have like a DA ranger or DA warrior or something, and you can have like templates. And then players, as they play, they can modify it, do their own thing, but you can kind of have templates for it. So yeah, there is a bunch of different uses. This is one of the data structures that are pretty useful when you start using them. They kind of work like any object where you store data, you can access it, you can modify it, you can save it, and you can do basically whatever you can do with a normal object blueprint class that you can do in blueprints. So yeah, those are data assets. Keep in mind, all of them have pros and cons. You don't want to use just, let's say, arrays for everything, maps for everything, data assets for everything. Use them in the way they're kind of meant to be used and think of the pros and cons of each data structure.